Hey everyone, thank you so much for joining us today for another NYOUG Viscosity webinar. My name is Monica Lee, Marketing Director at Viscosity North America. I'm super excited to have my colleague presenting for you guys today, Sean Scott. If you have any questions during today's webinar, there should be a questions panel for you. Feel free at any point in time to submit questions there. Sean will see them and he'll get to them whenever he can. If he can't get to them to the end, he'll do that as well. And if we run out of time, we'll also be able to respond to you afterwards. So no worries, me and my team will also reach out and provide slide decks to you, and hopefully maybe late today a recording of today's webinar. So if you're not familiar with Viscosity, we are an Oracle partner and we are a system integration and full Oracle stack consulting firm specializing in things like health checks, performance assessments, performance tuning, cloud readiness assessments, zero downtime migrations, Oracle Apex, and custom app development. We've got a lot of webinars and free educational resources for you at our website. So if at any time you're interested in seeing what's coming up, please visit viscosityna.com/event. We've got an awesome master panel coming up next week, also co-hosted by NYOUG and a few other regional Oracle user groups. You can see that there on that webinar, on that web page as well. We've got guests like Maria Colgan and Andy Rivenes from Oracle, as well as my CEO, Charles Kim, and our CIO, Rich Nemec. So it's definitely something you don't want to miss, and I'll send you information on that as well. With that, I'm going to turn it over to Coleman from NYOUG. He's going to tell you a little bit about their organization, how to get involved, and he's going to introduce Sean to you.
Thank you, Monica, for the introduction, and welcome to our series on the webinar series shared with Viscosity. So the New York Oracle Users Group has been around since 1984 for the exchange of ideas and support of the Oracle products. You can connect with us on Twitter, Meetup, LinkedIn, Facebook, and of course our website, nyoug.org. Also outreach to all the membership in the Oracle user community by going to the community.oracle.com user group website. And again, thank you for Viscosity North America for co-hosting these series of webinars with us. A little introduction about Sean Scott. Sean has worked with Oracle Technologies as a database reliability engineer, database administrator, architect, and developer since 1995. Sean specializes in RAC, database migrations and upgrades, database reliability and resilience, replication and performance tuning. He contributes to the Oracle community as a regular presenter at conferences, spent many years as a vice president of the San Diego Oracle Users Group, and currently serves on the board of the Real Application Special Interest Group and the Collaborate IOUG Database and Technology Committee. Again, thank you, Viscosity, and thank you, Sean, for presenting today.
And thank you, Coleman, for the introduction and for having me as part of your user group today. Let's see. And there we go. All right, we are sharing screens, yes? Can someone confirm that you see my screen there? Awesome, great. Let me just rearrange a couple things here so that I can see everything. All right, great, thank you. Again, thank you, Coleman, for the introduction, and NYOUG for being here and having me today, and for everyone who is attending today as well. I am going to talk to you about running Oracle database upgrades on Docker. This is pretty much what Coleman just talked to you about, and I am a member of the Oracle ACE community, and if you're not familiar with the ACE program, it recognizes members of the Oracle community for technical contributions to Oracle technology. So if you or someone you know is active as a presenter, as a blogger, or they work behind the scenes in your user group to put on events like this, and I know that even just doing a webinar is a a fair amount of work, if not a lot of work, I would encourage you to nominate them or nominate yourself, and you can do that here at this acenomination.oracle.com link. All right, with that housekeeping out of the way, this is a fairly technical presentation. So for those that aren't already familiar or comfortable with Docker, I want to take one slide to just kind of cover real briefly some of the technical content I'll be discussing so that you have at least a little bit of familiar ground to work on. So there are some terms that we use in Docker. The first is an image. An image is just a file system that contains all of the directories and files that we need to run something in Docker. An image for an Oracle database container would have its Oracle base and the Oracle home inventory, plus all the binaries and libraries and so forth. If you're familiar with Vagrant, and a Docker image is like a Vagrant box. It's a self-contained set of files. It's something that we can transfer back and forth and share with others, and everyone is going to have the same experience with an image, regardless of what machine or operating system you personally are running. A container is a process running on a system, and a container is run from an image. So images are static sets of files. When we start that image and run that image, we get a container, and that container is a process that we can interact with and that does work and so forth. A Docker file is a set of instructions for building an image. We'll issue a command called docker build, and all of Docker's commands are for the most part, pretty self-explanatory. It doesn't have a really broad command set to work with. But when we issue the docker build command, Docker is going to read through that manifest, that Docker file, follow the instructions in it to manipulate and create an image. And there are a set of commands that we can issue within a Docker file. From is one of them, and this is by no means the entire set, but these are the ones we'll focus on today. From tells Docker that we want to get something from an existing image, so it's like a starting point that we can work from. Copy does just what you might imagine. It copies things from one thing into another, and the thing that it can come from can be either files on your local system, or it can be another existing image. Run, as you might expect, runs things. So when we're building a container, when we're building an image, what we're actually doing is pulling an image from an existing repository, running that image, manipulating it, and when we run that image, we're running it as a container and doing things. So that run command, we can issue bash commands, script commands, we can call and run scripts and so forth. env sets environment values for you. And then we've got some commands here to look at. Docker build, which, as I mentioned before, builds an image. Run runs an image and creates a container. And then Docker exec and Docker attach allow us to create a session in the running container that we're working with so that we can interact with it or so that we can issue commands. And then finally, the last thing here is this link to a GitHub repository. Oracle maintains a set of scripts for building images for running Oracle databases, as well as a variety of other Oracle products. And this is the Oracle repository that contains all of those scripts. And these are the scripts that we're going to be working with. These are the images that we'll be working with and modifying so that we can run upgrades. So with all of that out of the way, I like to compare database migrations and upgrades to the World Cup of soccer or to the Olympics, because they have a lot of things in common. They're all very high stakes events. They typically occur infrequently. I think that if you're working in a shop and you have a bunch of databases, you're probably not upgrading those databases on a very regular basis. And the event and the participants that are involved in upgrades and the Olympics and the World Cup, they're under this great amount of pressure and scrutiny because this is your one chance to get things right. These things also tend to bring out experts. I know that if you've ever watched the Winter Olympics come around, people go crazy for curling, and the other 3 years and 50 weeks of the time they don't care about it, but people are tuning in at 3 a.m. to watch curling, and they're suddenly experts on things like ice conditions and stone weights and all of those things. And in the upgrade world, these are the equivalent to the cubicle surfers that swing by to let you know about the hidden parameter that they just found on Google. And on a serious note, there are very high expectations for success, and those expectations can eclipse the success of an otherwise exceptional performance if we don't quite hit them. All that we end up remembering is the failure. So as database professionals, what do we need to do to prepare for an upgrade? And the answer to that is we treat it like an athletic event. We train and we practice for it. Elite athletes and teams are going to drill and they're going to perfect fundamental skills until they're second nature. And this is where Docker enters the picture. Docker is going to be our gym. It's our practice field. And while Docker is very popular in a number of enterprises, and it's likely that you have coworkers that are using and working with Docker, it is not as highly utilized in the database space still. So if you're not a convert, if you're not using Docker already, I'll throw out a couple things for you. For one thing, it's free. It's also a relatively fast and easy tool to use. As I mentioned before, it doesn't have a really broad command set. There are a number of resources out there that are available to help you get up to speed rather rapidly if you'd like. There's a good chance, as I mentioned, that you have folks in your organization already that are working with and using Docker that may be able to help you work through some of these problems. Plus, most cities are going to have meetup groups, and there's free training online and on YouTube and so forth. I personally have a YouTube channel where I have a number of Docker videos, Docker specifically related to Oracle. Docker is also a very portable tool. It's an open standard. So the images that I build on my machine, whether it's my Mac or whether it's my Linux lab box, I can take those images and I can send them to any person anywhere. And they will work on that person's machine running Docker or any other similar container technology. It's not limited to Docker. I can take those images, I can put them into a private repository, I can distribute them within my organization, their code, so I can manage them under version control. So there are a lot of very positive aspects. They're also very light on system resources. I've got a MacBook Pro, it's a few years old. I think the most virtual machines that I've ever gotten running on it were 4-ish running database, and it was painful at best. I've had as many as, I think, 9 Oracle databases running simultaneously in Docker on that same machine, and I was able to, just as an experiment, run all of those for an entire cross-country flight on battery power, obviously. So why is all this important to us? It's important because we don't want to test upgrades in production. But Sean, you say, we are a sophisticated shop. We've got development and test and QA systems and stage and support. Why, our DBA team, get this, we've even got a separate set of database hosts where all we do is validate our recovery scenarios every week. Every month we do failover drills. So we would never, ever be testing in production like you're suggesting. We would start in dev. And to that I say, you're testing in production because every environment is somebody's production environment. It may not be prod, but dev is prod for your devs and test is prod for testing. And chances are probably pretty good that your employer didn't go out and purchase and provision a bunch of infrastructure, especially database infrastructure, to just sit around and not do anything. So we want all of that to be working. And if you can't take and break an environment for an unspecified extended period of time without any kind of consequences, without anybody complaining, while you run through those first few upgrade scenarios where you're still kind of getting the lay of the land, well, that environment isn't a place where you really have the luxury to truly test your upgrades, which is why Docker is great for this sort of work, because we can work out all of the details in a private space or in a team space. that doesn't have high provisioning costs. It doesn't impact any other users in the environment. And we have this freedom to build it and break it and tear it apart and blow it up and blow it away and rebuild it, and not have to fit any of that effort into anybody else's schedule or around anybody else's efforts. So from the standpoint of what we can do in Docker, there are a ton of things. We can build out all of our processes, make decisions about the method that we're going to use. Are we going to use auto upgrade? Are we going to use the upgrade assistant? Do we have to add any special scripts in? We can determine the exact steps that we want to follow, their order, any procedures that we want. We can build documentation and process around that, build automation around that. We can validate our different monitoring systems and our metrics. Plus, we can preview features and get an understanding of how our new database is going to work. The optimizer is a great example of this. If you're moving from 11G or 12C to 19C, the number of new capabilities is off the charts, just when it comes to the optimizer. You have other things that have been deprecated or removed. So learning how to work with the new optimizer behaviors, the new features, is going to be critical to your success, because we're not just going to upgrade the database, turn it on, and then say, okay, everyone's on their own, should be great. What we need to be able to do as database administrators and database managers is recognize the things that the new database is going to do, what those behaviors look like, and how we react to them. This is like training for those fundamentals. If you're an athlete, being able to do those very basic things, recognize those very basic things. So hopefully this sparks a little bit of imagination for you, and we're ready to explore how we can actually run these upgrades on Docker. So let's get started. So what do we need to do to upgrade a database in Docker? Well, we're going to need images, and I said images plural. We're going to need 3 images when this is all said and done. So for clarity, I'm going to talk about a source database. We'll refer to it as a 12C database. I've got a target database, that's going to be my 19C database. That's what I'm upgrading to. And in the following slides, you'll see some notes down at the bottom that say this is a step that you need to perform on source, on target, or on both. So the first thing we need to do is maybe step back a little bit and take a wide view of what our final image is going to look like for an upgrade. We need 3 things. We need a file system, something that has all of our binaries and libraries and so forth. And we need 2 Oracle home directories. So we're going to build this file system with all those binaries, and then we're going to add our source Oracle home, and we're going to add our target Oracle home. And then we're going to attach that target Oracle home to the database inventory. And again, we're going to do all of this with Oracle's freely provided GitHub repos for building images. But we need to make a couple of modifications to some of those assets first. If your target version, if what you're going to upgrade to is Oracle 18 or beyond, you're going to need to remove or upgrade the existing Apex installation in that source database prior to running the upgrade. You'll see a warning just like this one you see on the screen from the database upgrade assistant, the pre-upgrade jar, and it tells you you need to remove or upgrade Apex. And fortunately, the steps for removing Apex are pretty simple. This is the command for a container database. If it's a non-container database, you just remove the _con. So you just cd into that Apex directory and run that script. Perfect. The problem is that when we're working with Docker, we want those images to be fairly small. And so the default scripts go through and they say, gee, what don't we need in this final image? Well, we don't need this Apex directory. Let's get rid of it. So you'll go and you'll see that there's in the Oracle GitHub repo, there's this script called install db binaries, and it will include a line that looks like this that says rmrf Oracle Home Apex. And if you don't have that Apex script there, then you can't remove Apex. So we need to go into this script and just comment or remove that. The next thing is it's probably likely that you are not running a container database. But Oracle's Docker images, at least last I checked, are pluggable database only. So what we'll need to do is we'll need to go into the response templates that are provided with the Oracle images and change this create as container database equals true, change true to false, so that when we build our Oracle database on the source, we're not going to get a pluggable database configured for us. We don't really need to worry about this for the target home because we're not going to create a database on the target. So it's not necessary to make this change, but if you want to be able to independently create non-container databases in the target version, you'll do this there as well. And then we're going to build these two images as we normally would, and that's with this command right here, this build docker image.sh. And the instructions for this are all part of Oracle's GitHub repo. So we'll run that. And now we're going to have two images. When we look at this, we'll see our source image and our target image. So great, we have two images. How do we upgrade these images? Seems like we would want to have a target Oracle home in that source image or a source Oracle home in the target image. But as it stands right now, I just have two images. So we're going to blend those together. We're going to do one more step. We're going to create a brand new Docker file. What I've done in the past is just taken one of Oracle's Docker files, normally the Docker file that I would use for the source, for the target install, and I'm going to make modifications to that. So remember that a Docker file is going to start with an existing image. And in this case, I'm just going to start with this Oracle Linux 7 Slim. That's going to be my base image. And I'm going to add an environment variable to it. And that environment is going to be my target home. This is where my target database is installed. It's the Oracle home for my 19C database in this case. So I'm going to add that environment variable. At the same time, there is a script. Why don't I have that script name here? It's called setuplinuxenv.sh. So you can go into that setuplinuxenv.sh script, and you'll see in there, there's a yum install line. And if you'd like, you can do things like add less and strace and vi and tree and which. These are some of the things that I normally add there. I also add rlwrap, which is a wonderful little tool. If you're not familiar with it, it's great to use. So I'll go in there and I'm going to add those things. And this is again because Docker images are normally pared down, minimalist images that don't have a lot of things. The assumption is that we are not going to interact with them. So since we're going to be logged in and editing files and working manually within the image itself, it's nice to have some of these additional tools. And then we're going to do this wonderful thing called a multi-stage build or copy. So remember, we created our source image and it has our Oracle database, our Oracle home and Oracle base and so forth. And we've got our target image and it's got our Oracle home and Oracle base and so forth. We're going to use files out of those images to create a final third image. And this is where it gets kind of fun and cool. So this is a little snippet from down a little bit further down inside our Docker file. This from base tells us that we're going to start a new stage of our image build. And we're going to go from a named stage that we created a little higher up. I don't know if you remember or not, but there was this line right here where we said from Oracle Linux 7 Slim as base, we named this stage. So we're just going to skip down here and we're going to say, okay, we took that base image that we created and we're going to do two things. We're going to copy from the source image and we're going to copy our entire Oracle base directory from that source image. So what's included in that Oracle base directory path in a default Oracle installation? Well, it's going to be the Oracle home, it's going to be the Oracle base directory, and it's going to be our Oracle inventory. And we need all of those files because they're what we need to start up and run our source database, in this case, a 12.1 database. Then we're going to go and we're going to go to our target home, I'm sorry, to our target database image, and all we're going to copy from that image is the Oracle home. We don't want the base and we don't want the inventory, because what we want is a 12C image that starts out with everything that we need, but has 19C binaries so that we can run our eventual 19C database. But that 12C database needs to be able to start up. So it needs to have 12C in the Oracle base. It needs to have 12C in the Oracle inventory. We're just going to attach the target home in a later step. In fact, this step right here. So again, this right here is something you would see in a regular Oracle Docker file for a regular Oracle database build. And what we're adding is this command to run root.sh from the target home. So we'll set permissions and so forth correctly. And then we're going to run one more step here, which is this attach home script from the target home. And that is going to register our new 19C database home into the Oracle inventory that we created with the 12C build. And then the entire rest of our Docker file is going to be the same as what you would see in a regular Oracle Docker file. The one change that I made here is I added this port 8080, and this is so I can expose a port for HTTP, because with the auto upgrade tool, and I'll show you this in just a few moments, with the auto upgrade tool, you can run a simple web server in the Oracle home that will show you progress of the database upgrade itself. And this is a neat feature to have available because you can share the link to this with other folks in your organization, especially stakeholders in the organization, and give them some visibility into the upgrade itself and the progress that it's making, what step it's on, and so forth. And that's a nice way of building trust in your organization and visibility into the upgrade process itself. So we have this Docker file created. We're going to need to build this manually, and the build command is really not that tough. It's just this Docker build. We use this -t to give it a name, and what I'm calling it is Oracle Database, and then I just said it's 12C and 19C in Enterprise Edition. You can give your Docker file a name that isn't Docker file. So if you say that it's dockerfile.name, then you tell it the file name with this -f operative. And then notice that I'm running this in the directory where the Docker file is. So that's why we've got that little dot there. When we're all done with that, when that Docker build command completes, you're going to see that you'll have this brand new image, which is just about twice the size, or the sum of the sizes of our two original images. And this is where we're going to run our upgrade. So folks may be sitting there thinking to themselves, it seems like an awful lot of work to get to this point. What if I were to just take a 12C database image like I normally have and install a 19C database on it? I'll just copy the installer in there and run it. Two problems with that. One is that 19C has different binary requirements to build and compile and make the Oracle home that the 12C image isn't going to have. That's the first problem. The second problem, though, is, and this is less obvious, Docker uses something called a union file system. A union file system is read-only. So if I have my Docker image, I've got this layer that is my Docker file system. And as soon as I copy my 19C binary, my zip file, whatever it may be, into that container, it's going to create a brand new layer on top of that. It's a brand new file system layer, and it adds it there. And that layer is everything that was below it, plus all the changes. And then as I make changes and install and write new files and so forth, that's going to generate more layers. And then my container gets really big and unwieldy. So in order to avoid creating all of those additional layers and increasing my container size, we're going to do it this way because it lets us pick and choose just the files that we want and pre-create those directories. They're going to be essentially unmodified once Oracle 19c and Oracle 12c have been installed. From that point onward, they're relatively unchanged. Is there an easier way? I like to think that there is. I have my own repo that has an actual built-in upgrade image in it, and I have a bunch of other builds in there. So I have builds for running 11.2 for building databases 19.6 through 19.9, container and non-container. You can run DataGuard from Docker in there, although I have to emphasize, don't run DataGuard in Docker in production. That's a request from an Oracle product manager who emailed me after I announced this on Twitter. He says, no, don't do this. People are going to think that they can run it in prod, so don't do it in prod. And now that we've got an image, we're going to run this image as a brand new container where we can do our upgrade. This is where it gets fun. So this is a Docker run command that you might run into, and there are a couple of things that I want to point out to you. First is this -v command. I'm placing the opt Oracle Oradata directory in my Docker container. I'm mapping it to a local file system on my machine, and I'm giving it this name that's just the same as my container name up here. I'm assigning my own Oracle SID. I'm mapping port 1521 in the container to 1921 on my local host and 8080 on my container to 1980 on my local host in this particular example. And that's so that I can expose my database listener port and my HTTP port so that I can see them from outside that container. And then I'm referencing this image. I'll run this command, and then I can issue this Docker logs command so I can see a tail and see all of the activity that's occurring in the database. And then when I want to connect to it and interact with it, then I can just run this Docker exec command. One thing that I will point out to you is that you don't want to do this. Here I'm running an image, I'm running a container rather, and I'm calling it container1, and I'm putting my Oradata directory into this local file system on my computer. And then I go and I create a new container, run a new container. I'm using the same path. The problem with this is that my database is going to go out and it's going to create its data files and control files and so forth under this /data dir on my local machine. Both of them are going to try and use that same directory. The files are named the same way. You're going to have two databases that are overwriting information and trying to share the same control files and so forth, and that's a bad thing. You don't want to do that. All right. So once we run that container, what it's going to do is it's going to start up. It thinks that it's a 12c database. That's the Oracle home that we have. Those are the scripts and the configurations that we've passed to it. So when we run Docker, when we issue that Docker run command, it's going to start the container. It's going to look to see, do I already have a database? I don't. If I don't have a database, then it says I need to go out and run the database configuration system from my 12c Oracle home. It builds my Oracle database just as it always would. That 19c Oracle home that we've got is just sitting off to the side. It's just a passenger at this point. But before we can upgrade, we need to do a couple of things. The first is we would want to run scripts so that we remove the Apex directory or upgrade the Apex installation. If you are running auto upgrade requires that your database is in archive log mode. Database Upgrade Assistant does not, but auto upgrade does. So you'll want to set the database into archive log mode. And then you'll also want to do things like changing any init parameters in the database. One that is probably the most important for running a successful upgrade in Docker is the DB recovery file size. by default, I think it's 10 gig to have a successful upgrade. I normally set it, I think, at 25 gig just to give it enough space so that the recovery operations have enough room. This is an alert that'll come up if you run any of the pre-upgrade steps, and I don't want to get into the actual tasks involved in an upgrade, but if you run, for example, the pre-upgrade jar, or if you run auto upgrade in not deploy mode, in discovery mode, whatever the first one is, we'll see it in just a second here. It'll go out and it'll say, here are the things that are going to fail in the upgrade that you need to take care of before you proceed. And the recovery file destination size is top of that list. Again, we mapped a port earlier when we ran the container. So whatever that port was, we can use that port to connect SQL Developer to our database. And now that our database is up and running, we've got that running 12c database in our environment, we can actually go through the process of running an upgrade. One thing, if you are working with auto upgrade, you'll create a configuration file. This is an example of a pretty simple, straightforward configuration file. For your upgrade node, you're going to want to use the container name for that. Otherwise, this is all pretty vanilla in terms of the configuration file. There we go, analyze. That was the mode that I was trying to think of. Then at that point, you can run auto upgrade. The target home is going to have the necessary version of Java already installed, so you can just run Java from there, run the auto upgrade jar, reference your configuration file wherever you put it, and run it in analyze mode, review the results, and so forth. Then we can run it in deploy mode. Now remember, before I mentioned that I was exposing that additional port 8080, and the way that what that works with is if you go into your auto upgrade config tool logs directory, this upgrade auto subdirectory under there, and just run this command. This is a Python simple HTTP server. We're telling it we're going to run on port 8080. It is going to run a little web server on your Docker container that allows you to view this state.html file that is created when you run the database in deploy mode. And to give you an example of what that looks like, we jump out here and you see this is a running container here, and I've got this state.html file. And here I have auto upgrade. I started this earlier, and I'm just going to start it back up. And now I can see my status. But what I can also look at is this is the state.html page that I just mentioned. So I can see the status of my upgrade as it's running, as it's progressing. This page automatically refreshes itself every few seconds. So as this runs, we'll see this dictionary stats will change to whatever the next step is. There we go, just right on time. And so you can follow the upgrade as it runs that way. Cool little trick. I'd been working with auto upgrade for a couple of months before I realized that that was even a thing. All right, some tips and tricks when it comes to running Docker and Oracle. This is something I talk about in my presentations on running Oracle on Docker. And so I'm not going to get too deeply into it. I also have a couple of videos on this on my YouTube channel. But one of the things that's unique about Oracle's Docker builds is they put everything into the /ops/oracle/oradata directory. And that includes all of our configuration files. So they go into this extra little directory called dbconfig that you wouldn't see on a normal database installation. And these are links. These are the actual files. So this is your listener aura and your password file and SP file and so forth. This is everything that you need to run your Oracle database. And they are physically here in this directory the Docker build scripts switch those so that they're soft links to these destinations. So I have everything that I need for this database in this directory. And if you created this directory as a bind mount a little bit earlier, right here, when we issued this -v command, that means that all of those files aren't really inside the Docker container. They're physically present on my local machine's file system, which means that I could copy those to another directory. We'll call it gold, for example, and now I have a gold image of my database. So if I wanted, I could build this image and I could run it and have it build my database through database configuration assistant and so forth. And when it's complete with that step, if I copy that directory out, now I've got a gold image of an Oracle database already created. I can use that gold image and run another Docker Oracle container against that image or a copy of it, and just point my container using the appropriate path here to that directory path. And again, remember that the first thing Docker is going to do when it starts up, there's a script that says, do I have a database in this location? It's going to look there and it's going to say, oh yeah, I already have a database there. So it won't run database configuration assistant. It's just going to start the database. We already have all of the files, all of the configuration, everything we need. So instead of having to wait for the database to create, it's pre-populated for us. It's a neat little trick. And what that also means is that I can create point-in-time snapshots of the database. So for example, say you are running an upgrade, you get to a particular step that keeps failing for some reason, and you've got an hour and a half of preliminary work that you've got to go through in order to get to that stage. Take a point-in-time snapshot, start your database, point it at that snapshot, and now you're not going through the process. I'm sorry, I said start your database. Start your container, point it at that snapshot. It will start the container and it will start Oracle and it will bring it up at the exact point, the starting point where you've been experiencing these problems, and you're able to shortcut a significant amount of effort that is required to get to that point. So you can iterate over that, fix your problem, whatever it may be, find a solution and proceed on from there. Not that any upgrade ever goes anything but perfectly. One thing you want to keep in mind, or a couple of things that you want to keep in mind if you are working with gold images like this, or cloned images, after you've copied it to this new directory, you need to change a couple of things in the Docker run command. The first is, of course, we need to bind mount to a different directory, to the new directory we've created. We need it to be the same Oracle SID. You need to change the ports because you can't have multiple containers running on the same ports. You need to change the container name because you can't have two containers with the same name. And then you need to use the same image. But this run command will let you clone and duplicate multiple Oracle databases that look and behave exactly the same using that same base data set or gold image set of data that you're working with. And again, this is how you can do the snapshots of your containers as well, of your databases rather. So I think that I probably talked about this at the very beginning. There are some opportunities that we have available to us when it comes to running upgrades using Docker. The first set is looking at process, where we can test our backup and restore. We can validate the guaranteed restore point creation, guarantee flashback, demonstrate that we can move forward and backward with our database in that upgrade state. It lets you go through all of your documentation, perfect your process, make sure that everything is understandable and legible and obvious to anyone that might be involved in it. Again, we can get in and we can look at performance, see whether or not the new database behaves differently than the old database, things like that. We can get in and we can start experimenting with operations, DevOps practices. So building metrics, building out automation, creating our unit and functional tests and so forth. Iterating over tooling as well, making sure that monitoring is in place. Any new things that you might need to monitor are being captured and evaluated and made visible to your teams. And most importantly, and the point that I want to drive home here, is that Docker gives us an environment where we can practice this. This is our training field, and as I mentioned earlier, this is the thing that lets us train like elite athletes and like elite teams, build confidence in ourselves, gain understanding of things, set up that muscle memory. One of the things that you're going to run into when you're running an upgrade is inevitably something is going to break at some point. So would you rather be in your production upgrade and have something break and go, oh my gosh, where are the log files for this? Or would you rather have that production upgrade occur and go, oh, this broke, let's go to the log file directory and not have to Google the location? A couple closing thoughts that I'll just share with you. A couple of myths, having done more than a few upgrades in my time, especially at N18C, there's a myth that, oh yeah, we've got documentation that describes that. The problem is documentation isn't always current or accurate. I could tell you a whole story about a shop that was down for almost a full week and lost somewhere like $1 billion because they had conflicting sets of information, documentation written by consultants who were no longer there, that they had never tested. The two sets of documentation had different sets of instructions that were contradictory, and they literally sat there for 6 or so days discussing which was the best next step to take. So what documentation doesn't address are these things like the stress and urgency of the moment, having people calling you and chatting you and standing over your shoulder asking you questions. Another myth is, oh, well, our production environment is under change control. The older your system is, the more likely it is to contain some undocumented or some weird little idiosyncrasy that makes your environment a little brittle or fragile. If people say, oh no, you can't do that in prod because it might break it, that's probably a good indication that there's one of those little weird things out there. So definitely go out and take advantage of Docker to practice through these things and work through these problems and simulate that production environment as best you can in order to demonstrate that something works or that it doesn't work and that you need to add a step. And then the final one, success in pre-prod assures that we're going to be successful in prod. Speaking from experience, production upgrades rarely go without some sort of incident here or there. And the best way that you can prepare for the unexpected things are to make those fundamentals, as I said, second nature for you. So with that, I'm done. Does anybody have any questions? Questions? Anyone? All right, gone. Coleman, I will turn it back over to you. This is my contact information. So thank you everybody for attending today, and thank you New York Oracle User Group for hosting the event. I hope that you found it worthwhile. And again, if you come up with questions down the road, feel free to reach out to me at any one of these avenues. And I have a question, and I will be more than happy to respond. And okay, the question is, do you run all of these on your personal machine or remote servers? I do both. The demo that you just saw right here, this is a little lab machine. It's a little NUC machine that just sits on my desktop. But I also have Docker containers. I've done this on a local machine. I've done it on a Mac. I've done it on a VM inside of a Mac. So you're not really limited there. And then Alexander asked if there are any tutorials. this. I'm putting together something for my blog. Unfortunately, and I'm going to blame Monica here. Monica has kept me, and work has kept me too busy to actually put all of this into a procedural sort of handbook, but it is on my to-do list, I promise you. And I will hopefully have that for everyone soon. This is I'm sorry. And then we've got one more question here. Is there a replay available? Yes, Monica is recording this presentation, so it will go up shortly. And I think that she'll send you an email about that.
Sure
Monica,
will.
all yours.
Awesome. Thank you so much. As always, great presentation by Sean. Most of our presentations with Sean have a good amount of demo, and he gets nitty gritty and shows us some great stuff. So definitely keep up with Viscosity NYOUG. Follow Sean on Twitter. We do have things, like I said earlier, fairly regularly, so don't miss out. Yes, I will send an email out after this with Sean's slide deck. It will take maybe an hour or two for the recording to finish rendering, but once it's done, you'll have a link to rewatch that as well. And other than that, I think we're good to go. If you guys have any questions, please email us at hello@viscosityna.com. Hello, I'm here. And I think that's it. Follow Viscosity, follow NYOUG. We really do have speakers like Sean, and that, degree of expertise regularly, and it's always just great, and it's always free. So definitely take advantage of it. viscosityna.com/event. You can follow Sean at Oracle Sean on Twitter. Viscosity's Viscosity NA, and I'll link all things to NYOUG as well. So thank you all so much for joining. Did a few more questions come in, Sean? Let me see.
I've got two more that I'll answer here. One is Oracle RAC supported within Docker? Yes, it is. Oracle RAC is supported by Oracle officially for non-production. Docker for non-RAC is supported for production by Oracle. And one other question, any reference document or examples, I'll put this up on my blog, so oraclesean.com. And it'll also appear on the Viscosity site as well, on the blog page there. So I'll get that up, I promise. Sorry.
Sean is also one of our awesome consultants. So yes, we keep him very busy. All right, everyone, have a great day. We hope to see you again at our next webinar. Take care.